Next, we'll do solving velocity problems. Chapter 2, Part 3, Solving Velocity Problems. There's one equation. Velocity is displacement over time. We could write that. Velocity is delta d over delta t, which would be the final position minus the initial position over the final time minus the initial time. Oops. That would be a t. Now, like I said in an earlier video, I often leave the delta off the t because the initial time in a problem is virtually always going to be 0. So the final time is the size of our time interval. Occasionally you could say the same thing about position, but not always. So let's do some simple problems. A car travels 500 meters in 3 seconds. What's the average velocity? Well, average velocity is displacement over time. The displacement is 500 meters. The time is 3 seconds. And I didn't bring my calculator, but I think there's a calculator here. And maybe there's not. So I don't even have my phone in my pocket. Let's see, the zeros cancel, and 3 goes into 50, 3 goes into 5 once, 3, 2, 6, goes into 18, 2. I feel a repeating decimal coming on. Okay, so my answer for average velocity is 16.7 meters per second. And you had a long division lesson right in the middle of it. Why did I say 7 and not 6? Because I could see that this was going to be a repeating decimal, and so I rounded off to the tens place. That's about as simple as these problems get. You're given the distance, you're given the time, you divide and get velocity. Sometimes we are given 2 out of these 3 variables, but not these 2. And this is an example. A car travels for 10 minutes at 20 meters per second. How far has it traveled? So in this case, we're looking for delta d. So we do a little algebra, and we get delta d equals, how do I get it by itself? I multiply both sides by delta t. So velocity times the time interval. So the velocity is 20 meters per second. And the time interval, well, I can't just stick 10 minutes in there because my seconds won't cancel. But I made this one easy to convert. If there are 60 seconds in a minute and I have 10 minutes, wouldn't that be 600 seconds? And then 6 times 2 is 12. I need 3 zeros. 12,000 meters. Pretty simple. Okay, and again, we've solved for V and D. Now we're going to solve for T. If a car has traveled for 10 kilometers at 20 meters per second, how much time has passed? So if we rearrange this equation for time, we're going to get delta T equals delta D over our average velocity. The time will come up over here and we'll divide by the average velocity. And our displacement, I can't put kilometers in there, but again, I made this one easy. 10 kilometers is just 10,000 meters over 20 meters per second. So cancel those zeros. Well, 2 goes into 1,000, 500 seconds has passed. All right, pretty straightforward. For those of you who are not comfortable with the algebra and would prefer the triangle method, it's not my favorite, but I'll draw it for you. Delta D would go in the top, and V and delta T would go in the bottom. So velocity is equal to distance over time. Time is equal to distance over velocity. And distance equals velocity times time. So if you are a lover of the triangle method, then this will work for you. One slightly more complicated problem. If a person is walking on a trail and starts their walk at the 0.25 or at the quarter mile marker, then walks for 10 minutes at a pace of 0.05 miles per minute, where are they on the trail? The trail at the Y has markers, 0.25, 0.5, 0.75, and then the 1 mile marker. And so, where are they? What is their position on the trail? Well, remember our equation, average velocity equals final position minus initial position over time. Well, I know my initial position. What I need is my final position. So let's do a little algebra. If I multiply both sides by time, this gives me average velocity times time equals df minus di. If I want df to be by itself, which I do, then I would move this term over there. And that would leave me with df equals di, it's positive when we move it over, plus average velocity times time. So where are you? You are wherever you started, plus however far you've traveled while you were moving. So the velocity times time figures how far you've traveled while you're moving. Add that to your initial position and you'll get your final position. This equation is actually labeled as an equation in your textbook. So you can think of it as two equations, although you've seen this one is really the same as this with a little algebra. Okay, so let's solve the problem. Where are we? Well, we started at the 0.25 mile marker. Our average velocity was 0.05 miles per minute. Okay, I left a couple letters out, but don't get picky on me. Times the time, 10 minutes. Why can I use minutes now when I didn't before? Well, because this is minutes and they'll cancel. And this is miles. So the miles and the miles will add. So we're okay with our units. 10 times 0.05 is 0.5, right? And the minutes canceled, so this is 0.5 miles plus 0.25 miles. So the final position is at the 0.75 mile marker. Okay? Thanks for watching, and that's the end of Chapter 2, Part 3.